We are recording. Welcome to the evening of Python coding. This is part of the Austin Python meetup. Today we have Jason Deutsch. He's going to talk about the advanced Python schedule, and he's going to show us a live demo. Jason, go ahead and give us the demo.
Sure, thanks, Jacob. While I'm getting transitioned, I will just introduce myself. So yeah, my name is Jason. I currently work as a backend engineer on some cloud products at IBM. I serve as one of our team leads, and I am looking for my Present Now button. I just found it. I've been working with Python on and off for a little while. I'd say today I do about 20% Python, 80% Go, but don't hold that against me. So is this screen coming through well?
Yep, we got it.
Cool.
You're fine.
Okay.
Yeah, I see it.
Awesome. Thanks, guys. So yeah, I'd just like to share with everyone a library that I've made some pretty heavy use of at work. It is called AP Scheduler, or the Advanced Python Scheduler. And essentially, it is a library for scheduling code to execute at a later time. So if you're familiar with cron utility, cron jobs, kind of software like that, AP Scheduler provides you with that capability in your Python application. So there's a bunch of interesting things about it. One thing that I was asked before is, why would I want to use this when we already have Crontab or other software for it? And then kind of an interesting thing about AP Scheduler, it was really built to not be just a standalone cron tool. It was really intended to be integrated into your application. And we'll get into some examples of that. But when you're kind of thinking about scheduling things to run later, think of AP Scheduler as being a much more full-featured, I guess, Python-based alternative to something like Crontab, something you can really use in your applications. So in short, this is really something that allows you to schedule your Python code to run later. Let's just talk about some use cases. And all of these use cases that I'll share are things that I've either done myself or seen a colleague do at work, or have been something I've seen in production. So one thing that I've seen a few times is kind of daily payments tasks. So you can think about Airbnb or VRBO or sort of things like that, where the company takes in money for the rental, but at some point in time, the owner has to be paid out. And usually that's done by every day at some time, get all of the rentals and check if it's the conditions are met to make that payment. And if so, go ahead and do that. It's queued up every day, so there's no kind of human action or kind of manual API action that needs to be taken. Another big case that I've seen, and one that I've kind of used myself, is for recurring report generation. The clients that use our product today are big enterprise companies, and like big enterprise companies, they have big enterprise reports. That would be just kind of an awful user experience to have to go in and manually retrieve report every day. So one use case that I've seen and built is the ability to automatically generate reports on some interval that is completely configurable by the client. Maybe more commonly, automated backups, backing up kind of a server instance, a database instance, or just whatever, doing something with data every day or every hour or whatnot. So there's a ton of use cases for this type of scheduling. These are just a few. Some are really creative. I've seen people write these sorts of jobs to get the top post from Hacker News every hour and print it out to the terminal, or to send a text message if server load suddenly increases. So definitely something that you can have a lot of fun with. If you're not familiar with kind of cron in general, cron jobs, and this is a bit of a detour, but I think it is a little helpful for kind of contextualizing all this. There is a cron syntax that is usually marked with 5 or 6, I guess, options. And you can see them here: between minute, hour, day of month, day of week, so forth. So some examples of what that would translate to is if you just had 5 asterisks, your job will run every minute. And if you have 2 zeros and 3 asterisks, well, that will run every day at time 0, 0, 0. You could schedule a job for every Wednesday or a job that you only wanted to run right after the New Year's. Well, this job 0011 asterisk will only run January 1st at midnight. So if you're interested in following along with this, here's what I did just to simply get set up. Just create a virtual environment, activate that. We're going to use 2 dependencies, AP Scheduler itself, as well as Flask. Pip install those, and you should be good to go for everything else in this little demo. So the first thing that I'd like to show is just a basic blocking scheduler. Now, there are a lot of components to this, so I'd like to just show this quote unquote in action first, and then we can kind of look at some of the ins and outs of AP Scheduler. So the code here is pretty straightforward, just importing a blocking scheduler. I am setting daemon to true, but that actually doesn't matter in this case. And I'm adding a job. This is taking 3 arguments right now. I'm just providing a lambda, which will define the job that this scheduler will perform. In this case, that's a very boring action of just printing out the jobs in the scheduler. So pretty self-referencing. We're not running it on a cron, we're just running it on a simple interval to run every 2 seconds. So let's run this. And we should see this printing out every 2 seconds the job. So what it's sharing here as part of the job sort of definition is it shares the job itself. That's what the kind of 2 carets in the lambda are about. We see its trigger intervallic every 2 seconds, as well as its next runtime. And that kind of rightmost column is really the only thing that's updating here. We're seeing that after the job completes, the job knows that it will run again 2 seconds into the future. So let's talk a little bit about what makes up Advanced Python Scheduler. This chart here has quite a few items, and I'd like to touch on each of them. A good way of just kind of quickly taking this all in is you have kind of 4 major components and a major concept: the executor, scheduler, job store, trigger, and job itself. And then kind of specific instances for particular use cases there. So I'll come back to this chart in a second, but just to cover what each one of these major categories are. The job is sort of the central behavior unit here. It's the function, it's the parameters for execution, and the scheduling parameters. Scheduling parameters are pretty obvious, or the execution parameters can be pretty obvious. Scheduling parameters control scheduler behavior, intervallic, cron, one-off, things like that. We also have our trigger. Each job will have its own trigger, and that determines when the next job of that job instance will run or execute. Of course, we have the scheduler. That's sort of the puppet master, the master coordinator. That's what actually manages the job store, and it also manages the execution. There are a bunch of subclasses of that for specific use. So coming back to this chart, over here towards the top left, we have kind of the ones that I am most familiar with: the background scheduler, async IO scheduler, but there's also ones that look pretty interesting that I haven't used: tornado, Devon, twisted, and whatnot. So if you're going to use this in your application, you'd want to get a specific kind of scheduler instance or subclass that matched your use case pretty well. So there's kind of 3 main built-in scheduling systems to use here. Cron style scheduling, that's what we spent a bit of time talking about earlier. Interval-based, that's what I just demoed, where we have the parameter interval and we set seconds to 2. There's also the one-off delayed execution. I want this code to run in the future, but I don't want to do it that many times. So kind of coming back to that could be maybe like send a a follow-up email to a customer. Customer signs up for some SaaS product. Let's add to the scheduler to send them an email in 1 week with a survey about their experience. Also important is the job store. That's what stores the jobs. By default, and in our example and in our next example, we didn't define a particular job store, so we just default to an in-memory job store. Of course, if we were to restart our application, we would lose all of our jobs, which is okay for this demo, but not okay for production. In production environments, I've used Mongo, but you can also use Redis and a number of other persistent stores to make sure that your job store will survive restarts. And it's also good for kind of adding multiple schedulers kind of for the same job store. Here you can see you can also use Zookeeper, which sounds very interesting, as well as RethinkDB, but I'm sure there are bindings for relational job stores as well. Finally, we have the executor. That's what actually runs the jobs. It manages the life cycle of the jobs. And you do have some fine-grained control there. You can choose between threads or processes or kind of other parameters. If you're curious about how those jobs get executed, then check the docs. I haven't had to do really much or any tweaking with executor parameters. Default settings seem to be just fine. Cool. So we've covered a simple example. We've covered the major components and some use cases and whatnot. So we'll take a look at a slightly more complex kind of use case, or at least one that I think kind of helps frame how you might use this in, perhaps an API. So in this file, I'm just putting together a very basic Flask JSON API. We have our imports. Here I've defined what I'm calling a queue. Is just a list, because you're going to see that the job that we're going to schedule is very basic. But this will just help us sort of keep track of what's been executed, so we can sort of see that really easily. I've defined a couple of endpoints here that kind of map to some of the methods available on the scheduler. So we're exposing a endpoint for getting a job, and that will just get the jobs from the scheduler. Once we've gotten the jobs from the scheduler, we can kind of request a specific instance by ID. Of course, we can add our jobs. Here you can see a few more parameters for adding a job than earlier. We have a lambda that just is going to append a random number between 0 and 100 to the queue. And we're giving it the name my job. We're also exposing an endpoint to control the state of the scheduler itself. So we can start it, pause it, shut it down, or resume it through these endpoints. And this is pretty cool to me, just because one thing that I've enjoyed about AP Scheduler in production is really using it as a service. So the organization I work with has many teams, and we have a very large architecture. The team I'm part of creates what we call our common services, and that's stuff used mainly by other teams in building their services. And one thing that is pretty interesting is just kind of a distributed general purpose scheduler as a service for all of our other applications to use. So let's start this up and play around with some of those endpoints. Okay, so right now we've kind of looking in the code, we've instantiated our scheduler as a background scheduler. And that's why this is able to work. What we saw in SimpleBG wouldn't work here because it was a blocking scheduler. Once the schedule started, it would occupy the main thread, and nothing else would be able to execute if we just kind of newed up a blocking scheduler at this point. So the first thing that we should probably do is just start our scheduler. It's worth noting that we could add jobs to that scheduler right now. That class instance is alive. It's just not running. The executor is not going to run any jobs. So we should be able to start that, and we get back as a response a state of 1. So 1 maps to running. So from there, let's just do a little sanity check, make sure that we don't have any jobs we haven't added any yet. So that should be empty, and it is. That's great. And let's go ahead and just add a job. Again, this is just adding the same generic job of adding a random number to our list every 5 seconds. Cool. So we've added that job, and in a production environment, we want to be able to take that job ID, perhaps by hitting an endpoint to get all of our jobs, and then query to get some information about that job. So here, this is just a pretty simple example, but in a production environment, you might want to have information about past job success or failure, the next runtime of the job, when the job's going to run again, things such as that. So, and last, just a simple endpoint to query our queue to see the numbers we've added into it. So it's been about 30 seconds since we started that up, so we see that we have a few numbers there. If we wait a little longer, our last number at the end should change from 54 to something else. So now we've had another 10 seconds, 98 and 60. We could get this job to run a bunch more times. We'll add more jobs to our queue here. We can see that our job store is our scheduler is now managing many jobs, and that our queue is expanding, and will eventually crash and run out of memory because there is no cleanup. So coming back to our state management.
Some comments. Some people are asking to increase the font size. Someone's asking which environment main.py is running in.
It's just running in my virtual environment. Yeah, just running my virtual environment, and I just installed AP Scheduler and Flask. So is this better for the font here? I will assume that it is. So now that I've increased this, I'll just quickly recap. We've started our schedule. We've put it into kind of a running mode. We can also send it a pause signal, which returns a state of 2, as well as restarting it with a resume. So its state goes back to 1. We can query to get a list of all the jobs that our scheduler is managing. And now that it's been some more time, our queue-like structure should have quite a few more items in it. And we can see that it has over 100 now. And of course, we can shut down our scheduler. So yeah, that is the gist of AP Scheduler. Again, it's something that I really enjoyed working with. I found it to be pretty useful. Something you can really get creative with, just thinking of things you might like to do given some criteria, either on a regular basis or at some time later, without having to get into the weeds of managing those individual executions. I hope this was informative. That concludes my demo, and happy to answer any questions.
So I see Eric is asking, the center of that window will show a hover of 3 icons. Is the question, or is it a statement, Eric?
Just comments about how to make the presentation bigger on the user's end.
Okay, sorry. Yeah, so I have questions to start. First of all, does it work in all environments? Windows, OS X, Linux?
It definitely works in Windows and Mac OS. Or I'm sorry, it definitely works in Linux and Mac OS. As far as Windows goes, I'm not sure, but I can't imagine a reason why it wouldn't.
Well, some libraries work on some environments and not in others. So you haven't tested it on Windows. This is the answer, correct?
No, I have not tested it on Windows.
Okay. So this is the first one. Second, You said that there are multiple engines underlying that's underneath. Like for example, Cron. You can use Cron or something like this. Did I get it correctly, or was it something else?
Yeah. So when you're when you're creating a scheduler, you can there's a base scheduler class, and you can instantiate a specific subclass. So the two that I demonstrated tonight were a background scheduler and a blocking scheduler. And that just has to do with, that really changes how the scheduler kind of runs in your system. The blocking schedule runs in the main execution thread from which it's called. The blocking scheduler runs essentially in the background. As far as the triggering, that's where you can choose between how you're going to define when those jobs are run. So you can use a cron syntax, I want to run this every third Thursday of March, or an interval. I want this to run every hour or every day. We could also do the same thing with cron as well. There's also kind of one-off. I want this job to execute in 7 hours from now, or on a specific day.
What happens with jobs that have errors or something that is unhandled or gets stuck for some reason? What happens to the schedule? Does he know about that? No? Tell us.
Sure. Well, for the most part, the scheduler it's not the scheduler's responsibility to handle an error with the job. So the scheduler itself is just going to kind of move on once it executes, sort of like a fire and forget. One thing that I've done is, if we have the client that's going to, I guess, receive the results of the job execution can send sort of like an acknowledgement back to sort of the API that provides the scheduler. Or it can actually provide a signal that something went wrong and it needs to reschedule. But again, some of these might, so I guess in the case of payments, if paying out to a kind of Airbnb rental property owner failed, and that was a one-off job and it's not that we're going to get it tomorrow, there might be another scheduler that will do one-off jobs, will run immediately, or the application might decide to run it immediately at that point in time.
So the application has to handle issuing back the failed job to the scheduler, correct?
Well, it depends on how you define it, right? So and it depends on the nature of your job. So like in the case of a payout, that's a job that is going to change the state of a rental. So have we paid this owner kind of their cut from the booking? So the result of that job should be a state change on that kind of booking information in the database. So if that failed to properly update because that procedure making the payout failed, then the next time the scheduler looks to say, hey, who do we need to issue payouts to, that job would be part of it. But any special handling wouldn't be on the application side. It's very similar to like a message queue, like an APM queue, like a RabbitMQ. The message queue isn't going to handle failures for you. You can either sort of fire and forget and not worry about those failures. You can also request subscribers to that queue to send an acknowledgement that the message was successfully processed, and if that acknowledgement is not received within some period of time, you can re-enqueue that stuff. But the scheduler itself is very concerned with scheduling and specifics of handling the failure of a job. Since the job is sort of generic, you can provide any function as your job definition is on the application.
Okay, you lost me here. Some things I know, complex things are handled by the application, but there are other things that the schedule itself can handle. Like you're saying, if you didn't get an acknowledgement within X time, can it resend that does it have such logic or not?
No. That was an analogy. I mean, I guess a good way just to think about this is the jobs that the scheduler is going to run are kind of unknown to the scheduler. It just knows to execute some code. It doesn't know what the expected behavior of that code should be or how you're going to handle it.
And
So any
it doesn't wait for an acknowledgement or anything like this. So, like, does it know that something is executing now, or once it's executed, the job is no longer its concern, and that's it? It forgets about it.
right, for the most part, yeah.
Okay, so because we were talking about Dask the other week, which is not exactly, but it's like a queuing system. And one of the things that we're talking about is also a system called Prefect, which actually allows you to handle those failures and tell you what to do. So anyway, this is just ties up to what we're doing in the past, and well, maybe we should do Prefect in the future. Someone has to volunteer.
Sure. Yeah.
Any other questions by anyone? You must have questions. Quiet. Okay, if everything is understood and we have no questions, we might want to close the recording. So let's give it one more time.
I have a quick one, Jacob.
Go ahead.
So you mentioned this as an alternative to a cron job. What about its, I guess, timing or its waiting is more efficient or not using resources in between, I guess, time points where it's going to run code?
Yeah, so even in the documentation of this, and if I came across as saying don't use Crontab and use this instead, then that wasn't my intention. This AP scheduler was designed to not really fill the niche of being a background daemon kind of cron service or a direct alternative to Crontab. This was really built to be a more featureful scheduling system meant to be used inside of another kind of Python-based application. So if you have a job that you're running with Crontab, that's just doing its thing in the background, keep using that. If you have more complex needs in your software, then go for AP scheduler.
Any other questions? No, Silas, go ahead.
Did you get Sherry's question there about the arrow conventions? Can you explain the diagram shapes and arrow conventions?
Oh, the cron syntax? This?
The network flow diagram with the jobs.
Oh, this guy?
Yeah.
Yeah, these are the components of AP Scheduler. So this is really just kind of the classes available to you in the major concepts. So as the base classes, you have a job store, a scheduler, an executor, a trigger. You have specific instances of those classes that are tailored to specific use cases, and that's where you get these outer boxes. So with the scheduler, you have a number of specific instances like a blocking scheduler, Qt, async IO, background, etc. And same for the job store, you have your base job store class and specific instances of that class, like the memory, the default job store, MongoDB, Redis, etc. Does that explain it?
Can you? I have two questions actually about this. First of all, when you install AP schedule, like pip install it, it actually comes in with Python, correct? Or does it have to be installed pip installed or conda installed?
If you pip install AP scheduler, it's just bringing in AP scheduler. It's not going to bring in anything else.
Okay. And Sherry is asking us about the diamonds. Maybe answer her first. Classes are rectangles, instances are used for use cases, and you have some diamond pairs. What are they?
Diamond pairs. So these kind of white arrow tips, that just means that like Tornado Scheduler is a instance of the base scheduler, and these black diamonds, I believe, just represent what is used by kind of the other class. So the job class will use a base trigger, or maybe the scheduler the base executor is used by the scheduler. The job store is used by the scheduler. So that shows the relationships between the different classes, as well as the specific instances of the base classes.
Okay, I'll go back to the question I was asking for. So, for example, you don't need to install a Tornado, or does it install it for you as a dependency? I'm curious, like how it interacts with the different systems. Like, for example.
Oh, yeah. This is a representation of the classes in the AP scheduler library.
So
you get all this.
So it installs you have to install Tornado to use it or not? I'm curious about how does the dependencies install. Does it install like a bunch of things there? Like for example, Cron is not something that you usually find on Windows. So it won't install Cron. It probably will tell you if it works on Windows. It probably will tell you not. I'm curious. I just don't know.
Sure. I mean, I would have looked at these as external dependencies to AP Scheduler. This is just what makes up AP Scheduler. So I'm in the AP Scheduler library right now. And where am I? I'm in the background scheduler, and you can see that the background scheduler is importing a base scheduler and a blocking scheduler itself. So this is just the library. So when you download the library or pip install the library, you're going to get all of these packages or all these files.
Well, I guess I'll have to check it out myself. Okay, that's just interesting. About the base store, what do they? Can you give an example of how those are used? The stored, like for example, the database. Like there's the MongoDB thing. What are like the job store? Sorry, not the. Like I see like a Redis job store or a MongoDB job store. What or how would you use those, for example?
Yeah. So if you don't provide a specific instance of a job store, then your job store class is going to be defaulted to a in-memory job store, right? So in order to use the MongoDB job store, you'd have to create a instance of the MongoDB job store class, and provide it with the proper configuration variables for your scheduler.
So why is this useful? Because all of your jobs will be documented all the time in MongoDB, or the outputs, the inputs.
Okay, sure. Yeah, I mean so if all you're using is the default job store or the in-memory job store, you have no ability to kind of replicate that, right? So it's going to be very much tied to the running application instance. So, excuse me, in my for example, in this example here where we're building this kind of queue of numbers we've randomly generated, if we restart this application, that's all gone, right? So there's the only way to persist your jobs data is to use kind of another specific instance of that job store, like the MongoDB job store, for example. It's like not having a database to store your user data. Once your server restarts, then it's all gone.
So in case your computer dies and you don't want to lose all of your progress, you just have to go back and now you can reload this. This is basically what you're telling me.
Sure. Yeah. I mean, also, if you wanted to store, millions of jobs for some reason, you might not want to keep that all in memory. You might want to put that on a kind of a dedicated server that had a database on it to store your jobs.
Oh, this is important. Thank you.
Another specific instance that I've dealt with is in kind of tenancy between single tenant situations and multi-tenant, and being able to rebuild a job store after migrating servers. So
you want to keep things running while not interrupting service. Nice.
Right.
Okay. Interesting. Okay. So it is built very well. Very nice. Anyone has any more questions or?
Yes. Sherry was asking again about the diagram, what it means, what the double rectangle means, and what the filled versus the unfilled diamonds mean.
Filled versus unfilled. So I see arrows and I see filled diamonds. Actually, no, there is an
the job,
unfilled
the base
diamond.
job score.
Yeah, I have no idea what that means.
Oh, all right.
Sherry, it's a diagram. We need to put in the source where it came from.
Yeah, I posted a link to the source and the context if you want to follow that up and see what they're getting at.
Yeah, and the key thing here is just to see all of the things that are available to you. That your job store can be in memory or persisted. You can run your scheduler in the background or in a blocking process. You have different options for triggering as well as for execution. So much more of a high level overview.
Okay. I like it.
Cool.
Anyone else has anything to ask, or should we stop the recording?
Oh, Sherry's also asking about the Cron diagram. Or
Sure. Yeah, there's a lot to cron syntax. So if you're curious about learning more, then I recommend a website. I think it's called Cron Guru. Yeah. So this will help you and is kind of an interactive way to write cron expressions. So this expression translates to at 4:05. If we take that out, this is at minute 5. So this will be at minute 5 of every hour. All asterisks would be at every minute. I'm not sure what happens if we do this. Okay, so now we can run this. This cron expression translates to at every minute on Wednesday. So it's just a scheme, a very versatile scheme for kind of defining a time or interval.
How do you do this every 5 minutes?
Oh boy. So that should be...
It's probably 5, 10, and so on. You have to put in the value list.
Yeah, so each one of these spaces correlates to like a minute. So the first one, or each one of these asterisks is a minute, hour, day, so day of month, and then day of week.
And below it actually shows you exactly the syntax. Very nice.
Yeah, so this is super useful. I've never tried to even get close to memorizing it. I just always come here to do. So at every 3 minute past hour 3, at every minute past hour 3 on Fridays. So that's fun.
Nice.
But only in December? Yeah.
Cute.
Yeah, fun stuff.
Okay. I think that this is enough for now, unless someone really feels the need for one more question. Okay, good. So going out once, going out twice. Before we finish the recording, I would like everyone to unmute yourself, and we'll have an echo, but please thank Jason for his nice presentation. So unmute yourself, please clap.
Yay!
Okay.
If anyone has any burning questions, you can come to the algorithms meetup and ask me. So.
Okay, now we know where to find you. I'm going to stop the recording now. Stick around.